Okay, welcome to Advanced Earth and Space Science. Today was the presentation from day one of the full day, and we start each day with a reminder to please put your phone in the caddy by the front door, and then usually there'll be some kind of opening activity, and then a question or two that are going to deal with the topics for the day. So today's was what is science and what is the difference between theory and law, and we had time to think about that and discuss that in class. And then when I went into the presentation, and I just wanted to say congratulations because you're here. And getting here wasn't easy. Trillions of atoms had to assemble themselves into an intricate and obliging manner that has never happened before and will never happen again. For the next many years, I didn't type all that out. These tiny particles will engage in delicate and cooperative efforts to keep you intact and let you experience what we call existence. But how many are trillions? That's a big number, and sometimes numbers get so big we lose track of just how mind-bogglingly big they are. So, if you were to look at, let's start with a million seconds, um, and how big is that? So, if you looked on a calendar, how long would a million seconds be on a calendar? And I asked that, and I got a lot of suggestions from the students as to how long that would be. And the correct answer was about 11 and a half days, 11.5 days is a million seconds. Okay, now, how long would a billion seconds be? So don't forget, a billion is like 1,000 million. And we talked about that and we tried to guess, and we came up with 31.7 years. So to go from a million to a billion, the next scale up goes from 11.5 days to 31.7 years. It's actually 31.7 some more if you look at all the significant digits in there. And then you go, how long is 1,000 billion seconds, which would be a trillion? How long would a trillion seconds be? And that's 31,700-ish years, which is about 5 times longer than human civilization has been on Earth. So as an organized society is in that probably about 7,500 years for us, and a trillion seconds is 5 times longer than that. So that's just incredible to look at how many cells, how many atoms make you up to make up your cells and all that. That's a lot. And these mindless particles themselves, they're not alive, but you are. And for some reason, after about 650,000 hours, hopefully more, they will shut you down, silently disassemble, and then go off to be other things. But in that time that they are you is one of the greatest things ever. It hasn't happened anywhere else in the solar system that we know of. And you're unique, and that makes you special, and that makes you amazing. So it's amazing that you're here, and we're happy. But everything is made of atoms, everything. And atoms are spread all across the universe. So does life exist in another solar system in our galaxy? In our galaxy, we have approximately 3,200 stars that have planets out of the approximately 1 to 400 billion stars in the galaxy. So we've actually observed 3,200 stars that have this tiny little wobble that we estimate is the presence of planets orbiting them. So, I mean, that's a lot in just, a small sample of what we can see in our own galaxy. And so if you ever go to a really dark place and look up at the sky at night and you see this milky, cloudy strip going across the sky, that's the Milky Way. And this is a picture taken with an iPhone 13 on a dark night in a cabin by a lake where it was really dark, and you could see these things. And you could see so many stars in that picture, and you could see the Milky Way. And if you then wondered how many galaxies are there in the universe, well, I'm possibly 100 to 200 billion galaxies in the observable universe. And just think if each one of those had billions of stars in them. That's a phenomenal number of other planets out there. And speaking of other galaxies, this is the constellation Andromeda. Let me get my mouse pointer up in here. Hopefully the camera picks this up. You have a star here, here, here that make up the galaxy, the constellation Andromeda. And then right up here, you actually have visible the galaxy Andromeda, which you can look at with a pair of binoculars. You could find that, and the iPhone 13 found it, and you could see it's spread out more, so it's not actually a star. That's a galaxy that's 2.5 million light years away. So actually, as you're looking at that galaxy, you're looking at it as it was 2.5 million years ago. It's taken that light that long to get here. So it's just incredible, um, how big the universe is, and how many possible stars with planets there are out there somewhere in the universe. And all these galaxies are moving, and some are moving away from us. And how fast are they moving? The farthest out galaxies are actually moving, we estimate, at 2 times the speed of light, twice the speed of light. They're moving away from us. Wait, how is that possible? Doesn't Einstein say nothing can travel faster than light? Yeah, how is that possible? Well, the galaxies themselves aren't moving faster than the speed of light, but the space between us, the galaxy, the universe itself, is expanding so fast. It's actually expanding faster than the speed of light, so that it takes their light that much longer to get back to us. Um, 32 billion years to reach us, moments after the Big Bang, making it appear that they're moving that fast. So, is it possible that there are more galaxies beyond the furthest we can see? Yes, it's possible that there are farther out galaxies who light cannot reach us because the space is expanding faster than the speed of light. So that light will never get here. I mean, that's just mind-bogglingly crazy to even consider. So we need some kind of a model, a physical representation to help understand that and explain that. So if you were to make raisin bread, when you make bread, you put all the ingredients together and then you let it rise for a while. And that's kind of like what the universe is doing. The universe is expanding. And in this example, the raisins themselves aren't moving within the dough, even though our galaxies are moving, but the dough expands and spreads them farther apart. So in the galaxy is expanding, but also the universe is expanding, but then the galaxies are also moving away at high speed too. So it's just unbelievable how big it is, and what we don't know. What we don't know is almost more confusing than what we do know. It's just absolutely crazy. So, other life, with 1 to 200 billion galaxies, possibly more, with billions of stars, there could be billions of solar systems with planets out there with a possibility to have life. The problem is getting there to meet them is going to produce too many problems. So, one last thing. In 2004, the Hubble Space Telescope took a picture of a region of space that appeared to be empty. They picked one area that didn't have much going on in it. And that area is about the size of the head of a pin held at arm's length. So if you have they like to say, so there's pins that have the little plastic tips on them. That, if you held that at arm's length, that's the area of the sky that it took a picture of, and it did a total exposure of about 11 days. And at the end of that, this is what the picture looked like. Thousands of galaxies. I think there's 2 stars in this picture somewhere, but there's thousands of galaxies just out there in space. And who knows if somewhere out there in one of those galaxies, there's a star with a planet with a bunch of students sitting in front of a teacher who's telling them just how big the universe actually is. All right. That was it for the first day lecture. I hope you enjoyed it, and I hope you enjoy the course, and have a good rest of your day.